Okay. Okay. Let's resume here. Okay. We just calculate the answer. I got the answer about the T value is 6.916. But remember, it's a little bit different from the area on the normal distribution because the sum of the area is 1, but about the T distribution is a little bit different. And you can, next time, if you are interested, you can move to here, go to the search engine and type T distribution, T table, and you will get a lot of useful information here. For example, I just copy and paste this one to you, and this one. 1 minute please here. Okay, and now let me explain here. Sure, later I will tell you how to use this website to do that, but now, not now. And for example, here, okay, how to use this table? Let me show you. Okay. Okay, I just copy and paste this one. Is from the website. Okay, now let me show you. Okay, here, and now, first of all, you can follow my steps. Turn on the table like this one, and now we can think one tail or two tails. What's the difference? Do you remember? Like this one. For example, two tails. We just want to know whether the value is in the center or outside of the center. What does it mean? It means it's not from the population or from the sample. It's totally different, but you don't have any evidence. And now two tails, for example, this one, the value is greater than here and here, the standard deviation here. Or like this one. And now, okay, we can use the website. For example, first of all, define the label. Generally should be 1, 0.05 or 0.01. For example, generally we set 0.05. It means the probability is 5%. If the probability lower than 5%, we think it's unusual. Okay, and for example, here, area of two-tailed, it means here. Okay, and the degree of freedom, check DF means degree of freedom from degree of freedom 1, 2, 3, 4, 5 until 12. But in our file, I just gave you the file like this one. Sorry, let me have that. So who is my file? All right. From the file, degree of freedom 1, 2, 3, 4, 5, 6, 7, and 9, 10 until here. And in our question, in our question, the degree of freedom and the number of samples were taken, that was 20. 20 minus 1, that is 19. That is 19. Thus, the degree of freedom in this case is here. Because n minus 1, 20 minus 1, that is 19. Is it okay? And next, we don't need to check the label. We just want to know one thing: the commutable probability if we set the 0.05 like this one. Of our label, that is 0.05, and in other words, it should look like this, and we can move. Like this. Okay, and the value is here. $1.729, and according to our calculation, the number is 6.91, greater than this value, then our number 6.91 greater than 1.729. Thus, we can say the p-value is here, very, very small. Then, since the p-value is less than 5%, then reject the non-hypothesis. Like this one, because our calculation, the score 6 is very great. It's very great, like here. Is it okay? 6.93, and this number we can check the number that is greater than. Where is mine? Again, the number was 20, and the degree of freedom minus 1, that is 19. That's 19. And we set 0.5%. 0.5% is here. Then we can move here. Get the critical area is 1.729. 1.729. But since the area, our calculation t-value, the t-score is 6.9, greater than this value, then we can say it's outside of it. Then move back. And the p-value is very, very, very small, very small. Then since p-value is less than 5%, then reject H none. Okay, so far any question? So again, now you can practice this one. Again, t-table. First of all, check the degree of freedom. Degree of freedom is n minus 1. Then select your probability 0.5, 0.97, sorry, 75, 0.8, 0.85, 0.9, 0.95. 0.95, it means the alpha is 0.05. And the other common is here, T 0.99. That is alpha equals 0.01. 0.01. Then after calculation, our t-value, 6.91. That's greater than this value, 1.729. 1.729. Thus, we can say is outside of the area. It's outside of the area. So is it okay for you? Okay, let's practice next question. Sorry, where is my file? Okay, next question. So where is my file? Come on. Okay, here. Okay, and here, and here. And now we can use this website. Actually, when I was a student, when my first time to learn the statistics, the moment there were no such useful free online applications. We need to pay. Actually, the campus pay the software fee. Okay, and here the t-value, degree of freedom, type 19, 6.91. And after calculation, very, very small. very, very small, right? Degree of freedom like this one. So the p-value close to small, it means completely they are different. Completely they are different. What does it mean? It means according to calculation, 20 people of famous people were selected, then test their IQ. Those 20 people, they are represent all famous people, and we got the answer. The average is 140, 145, 145. It doesn't matter, but the distribution is something important. After calculation, we can know the famous people are really smarter than ordinary people. Can you get it? Can you get it? Okay, let me do it again. Let me do it again. A random sample like this one, 20 of IQ scores of famous people were taken. Actually, only 20 were selected from this test, but they want to know whether they are smarter than ordinary people, and the average IQ is 100. Then after the calculation, the average is 145, but it doesn't matter. Two factors to determine whether they are different. The first, the distribution, about the standard deviation. The other, the next two is about the mean. The mean is 145. Here is 100, but we cannot adjust it just right now. We need to calculate. Then set the non-hypothesis. They are the same. Alternative hypothesis: the famous people are smarter than the average. Then those people, smart people, 20 of them were selected. The average IQ is 145. And standard deviation is 29.27. After calculation, the t-score is 6.937. Sure, my calculation is 6.91. It doesn't matter. Then get it. P-value n minus 1. That is 19. Then calculate the p-value. But so far, unfortunately, my traditional way cannot calculate the p-value. But this textbook uses this software, and I share how to use this. For example, the 6.91, the value, degree of freedom, and get a p-value 0. How about let me lower the size? .06. Okay, how do you think about the t-value here? We can get 0.05. Can you give me a hint? What kind of number I insert here, I can get the value 0.05. The answer is here. The answer is here. If we type that 1.729, it should be here. If two-tailed, here, 0.05. You can type 2.093. 2.093. 2.093. See? Can we get it? Confused? Sure, next week I will review this question again. Again, and let me, I don't want to, again, how to use the t-table, a little bit different from our previous practice. First of all, check the degree of freedom. Second, what is your question? On the question, we set one tail. So next week I will tell you the difference between one tail and two tails. 0.05. All two tails here. 0.05 here. Then check the value. Here is the value. If your t-score greater than this 1 is over t 0.975. You can think two tails, the alpha 0.05. It's significant. But when I was a grade student, it's difficult to calculate the p-value. But now we have computer, we can calculate very, very quick. Very quick. And again, if we type the value here, for example, when degree of freedom is 6, you type the 2.447 for degree of freedom 6, 2.447, you will get the p-value 0.05. You can try it. Degree of freedom 6. Oh, sorry, I forgot the number. 447, 2.447. 447, 0.05. Sure, in the future, I will give another website. Just insert population, mean, standard deviation, some easy numbers, then you will get all information you need. But not at this time. I still persistent to teach you to check the table from this one. Is it okay? If no more question, we can have a break now and see you next week. By the way, maybe the week of 15, 16, 17, I will select at least 1 week. We will move to a bigger classroom. We will have some drink or food testing. And sure, the TA and I, we are still struggling for some issues. And later, I promise you will test some drink or food, and we will make a survey. Later, we will use the survey data to do the statistic work. Okay, any question? Okay, have a nice Monday and see you next week. Okay, 1 minute, please. 2 minutes, please. Let me finish first. Okay. What's your number? Let's do digit. 57. 57. Jen. Lozada. Okay. No problem. Okay. See you next week. This part? Yes. Okay.
one blank, one mark per blank. 1, 2, 3, 4, 5 marks, and 5 more. Then how about next?
No. This one.
This one? Yeah, you should wear it. Okay. 5.
I have my calculation at the back.
So I think this part is okay. So
Okay.
the 2 marks, 5 marks. So you should have 7 more, right?
Yes.
Okay. So
I don't see any mistakes in my paper.
what was the mistake? So what's your question?
It shows that my answers were all correct, but I have wrong answer.
Because I gave the TA different answer, very close, because you wrong did up here first, then move to here, but I gave her the answer. I calculate everything, then round up to the 2 decimals.
Yes.
Then a little bit different. Okay. Okay, mommy, please. How about
This one, teacher, I rounded off to 1 decimal because it says 1 decimal.
Yep, it's reasonable. Okay. What mean please? Okay, 7 more, right?
Yes.
Okay. Okay, take it back.
Is it okay, teacher?
Pardon me? Yeah, you can take it back.
Okay.
And so can you line me again? I lost your information. Can you line me again? Send me a signal.
Okay.
Send me a text. 好，你先过去。
再帮忙先检查一下。
没关系，就给他们去了，我来关灯就好。